Methods of electrification. Some strange things seem to be happening on Rita's birthday. The balloons seem to be pulling her hair. The thermocol balls started moving towards the comb. Is this some supernatural force or pure physical phenomenon? Let's find out. When Rita combed her dry hair, both the comb and her hair became electrically charged due to rubbing. The hair attracted the balloon and the comb attracted the thermocol balls. Such localized charges are called static charges, and the electricity produced by them is called static electricity. Let's perform a small experiment. First, let's rub this glass rod with a silk cloth. When we rub the glass rod, it loses electrons and becomes positively charged. On the other hand, the cloth gains electrons and becomes negatively charged. Let us now touch these pith balls with the glass rod and see what happens. Okay. The balls repel each other. It seems both these balls acquired the same type of charge from the glass rod. And that's why they are repelling each other. That means like charges repel. Now, let's take another pair of pith balls. We will touch one pith ball with the glass rod and the other with the silk cloth. Well, the balls attract each other this time. Why? Now, it seems the pith balls acquire different types of charges, and that's why they are attracting each other. That means, unlike charges attract. We have a glass rod here, but is it charged or uncharged? How do we find that out? For that, we need a gold leaf electroscope. It's a simple instrument used to detect the presence of electric charge on a body. It consists of a copper rod connected to two thin gold leaves at the bottom end and a metal disc at the other end. The gold leaves are enclosed in a transparent container. When we touch a charged object to the metal disc, the charge from the object moves to the disc. The charge flows through the copper rod to the pair of parallel strips of thin, flexible gold leaves. On acquiring like charges, the gold leaves repel each other and therefore diverge. But if we touch the disc with an uncharged object, the gold leaves of the electroscope will show no deflection. The deflection of the gold leaves therefore indicates the presence of charge on a body. Can we charge all materials by rubbing it with some other material? Let us find out. Let us rub a metal rod with a piece of woolen cloth. Click the woolen cloth to rub it against the metal rod. Is the rod charged? Let's check this with the help of an electroscope. Click the metal rod to touch it to the disc of the electroscope to check if it is charged. No, the metal rod is not charged. Let's perform the same experiment again in a slightly different manner. This time, we will hold the metal rod wearing a rubber glove. Click the woolen cloth to rub it against the metal rod. Now, click the metal rod to touch it to the disc of the electroscope. See, the leaves deflect. That means the rod is charged this time. Why did this happen? How did a rubber glove make a difference to the outcome of the experiment? Well, when we held the charged metal rod with our bare hands, the charges flowed easily from the rubbed end to the other end, then through the hand, through the body, and finally into the air. This happened because the metal rod and our body are good conductors of electricity. The charge on the metal rod was conducted through our body to the earth. Consequently, there was no charge left on the metal rod, and so the leaves of the electroscope did not diverge. Materials that allow charges to pass through them easily are called conductors. Most of the metals, human body and tap water are good conductors. On the other hand, when we held the metal rod with the rubber gloves, the charges from the rod could not pass through the gloves and so could be easily detected by the gold leaf electroscope. Now, let's perform the same experiment using a glass rod instead of a metal rod and a silk cloth instead of a woolen cloth. Click the silk cloth to rub it against the glass rod. Now, click the glass rod to touch it to the disc of the electroscope. The leaves of the gold leaf electroscope diverge though we are holding the glass rod with our bare hands. This is because, in the case of glass, the charges were localized at the rubbed end and did not flow through the material to our hand. Materials that do not allow charges to pass through them are called insulators. Plastic, glass, rubber, wood are all examples of insulators. The process of charging a body is called electrification. Electrification or charging can be done in three ways: charging by friction, charging by conduction, and charging by induction. Click on each method to learn more. When we rub a glass rod with a silk cloth, electrons get transferred from glass to silk. So, the glass rod becomes positively charged as it has lost electrons, and the silk cloth becomes negatively charged as it has gained excess electrons. This method of charging is called charging by friction. When a charged body comes in contact with an uncharged conductor, charges flow from the charged body to the uncharged conductor, and the uncharged conductor gets charged. This method of charging is called charging by conduction. Observe this uncharged metal sphere placed on an insulating stand. An uncharged metal has equal number of positive and negative charges evenly distributed throughout its surface. Now, we bring a positively charged glass rod close to the sphere. The rod attracts the negative charges on the sphere, and the negative charges get accumulated on the surface near to the glass rod. At the same time, the positive charges on the sphere get repelled and move towards the rear end of the sphere. Let's now touch the rear end of the sphere momentarily. This will earthen the rear end. So, all the positive charges at the rear end leave the sphere through the hand, and only the negative charges remain at the end close to the glass rod. If we remove the rod now, the excess negative charges on the sphere spread evenly on the entire surface, and the sphere becomes negatively charged. This method of charging is called charging by induction. In this method, the charged body does not lose any charge to the conductor. Let's recapitulate what you have just learned in this animation.